Hello my friends and welcome to my channel. I have been reluctant at first at introducing this circuit because I needed to test its reliability first, but since it has been working flawlessly for about 3 years, I think it is okay to reveal it now. The photoelectric relay is a circuit that is used to control street lights. It will start running the street lights at sunset and they will keep on until sunrise where they turn off during the day. The circuit concept is very simple. We will energize a relay during the day and it will turn off during the night. This first element is the LDR, the light detecting resistor. It is a resistor whose value varies by light. When it is exposed to direct sunlight or any intense light, its value may drop to about 300 ohms, and in the dark it might go to 10 kilo ohms, 15 kilo ohms, sometimes go up to 100 kilo ohms. This is a normal resistor. It may act as a protection to this resistor, and we'll see how. This is the relay coil, and this is your AC source from the two sides, line and neutral. During the day, light falls on this resistor, so its value drops, and the value of this resistor is chosen, so it is low value or middle value, so that the sum of these two resistors in the dark is equal to the resistance of the relay coil. So when we expose when this resistor is exposed to light, this value will drop, and there is enough voltage to start the relay when it is delivered to the relay coil. Now, this is the control part of the circuit. This part is the power part of the circuit. During the day, the relay is energized, so this normally closed contact is open, and thus the load or our lamp or street light here is turned off. When the night falls, there is not enough light to keep the value of this resistor low, so it goes up to 10 kilo ohms or more. Of course, any relay coil will probably have less than 1 kilo ohm value of resistance. So when the value of this resistance increases, it will take most of the voltage supplied, leaving very little for the relay coil, so the relay is turned off. This contact goes back to the normally closed position, so we will have current flowing through the load, and our street light or the light, whatever light we want to control, will start running. Here you can see the components of the circuit, two sizes of LDRs in series with these resistors and the relay down. The design complexity of this circuit comes from the fact that you will have to calculate the ratings for these resistors correctly to make sure that they don't fail during operation. The relay coil internal resistance is almost 1 kilo ohm to 1.5 kilo ohms. Most relays will have that, and you can measure it. The LDR value in the dark may be about 10 kilo ohms, and I'm talking about the large size that is about 15 or 20 millimeters in diameter, and in the dark it goes down to when it is lit, it goes to 300 ohms. This resistor you can replace with another LDR in series, and it will give you a better performance. Here I am using, as I will show you, two LDRs of different ratings plus several resistors. The whole point is, during the day when the value of the LDR drops, this will take most of the voltage, so at least half the voltage must go to the relay coil to start it. Of course, it depends on its rating. The problem comes when you study the conditions in the dark. When this goes to about 10 kilo ohms or more, this means it will take most of the voltage so its power rating must support it, or you will also have to add this resistor, so it will take some of the voltage as well. In my circuit, I used 5 10 kilo ohms in parallel to give me about 2 kilo ohms. So when this goes to about 10 kilo ohms in the dark, I've got 2 kilo ohms here and 1.5 kilo ohms here. So this doesn't have to take 220 volts, but it will take something about 150, and this will increase its lifetime and prevent its failure. Here is another look at the components.